In this section, let's talk about the trigonometric functions of any angles. Section 7.4. Any angle without s, any angle. So in the last section, we already computed. In the section 7.2, we define the trigonometric function for the acute angles, because acute angle is the angle in the right triangle, right? In the right triangle, you have opposite, adjacent, hypotenuse. But if you have an angle bigger than 90 degrees or bigger than pi over 2, that cannot be placed in the right triangle. So you cannot define the trigonometric functions in the opposite hypotenuse stuff. So because of that, we are going to get a different definition for the trigonometric function for arbitrary angles. So once we get an arbitrary angle, we have to place them in the standard position. So standard position is here, the initial side is here, and then you get a terminal side. So this is angle theta. The angle theta. And what's next? You randomly pick up a point from the terminal side, and you measure. You record the xy coordinates of this point P. Okay, so the x coordinate is A, y coordinate is B. And then also you measure the distance between the P and the origin. So the distance between P and the origin is R. Okay, then what is the definition? So the sine of theta is always a y coordinate over R. Y coordinate over R. Sine is y over R. Cosine theta is x coordinate. X coordinate is A over R. Okay, so sine is related to y. Cosine is related to x. Okay, and then remember that sine, cosine, they have the property. The ratio is a tangent. So tangent of theta is defined to be y over x. Y coordinate over x coordinate. So this is y, and this is x. This is y over x. And once you get those three functions, you're going to flip them to get the other three trigonometric functions. So sine, you flip it, you get cosecant r over b. Cosine, you flip it, you get secant r over a. Tangent, you flip it, you get cotangent a over b. Okay, so this definition works for all angles. It doesn't matter where what is the value of the angle or where this angle is, where the terminal side is. You can always use x, y coordinate to define the sine and cosine. And we see that r is a distance. You pick up a point off the origin, then this distance is always greater than 0. My bad. The distance is always greater than 0. So these two functions are always well defined. For arbitrary theta, you always have sine and cosine. But, I say but, the tangent, cosecant, secant, cotangent, they are only defined when the corresponding denominators are not 0. Okay? So here you have to add one requirement or condition, provided no denominator equals 0. When the denominator is equal to 0, the corresponding trigonometric functions are not defined. Okay, when that happens, the corresponding trigonometric functions are not defined. Okay, so this is a definition. keep in mind sine is y over r, y coordinate over r. Cosine is x over r. Cosine is related to x, sine is related to y. Okay, let's see the example. Find the exact value of each of the 6 trigonometric functions of a positive angle theta if 4, -3 is a point on its terminal side. Okay, so we're trying to find the exact value of each of 6 trigonometric functions of a certain positive angle theta. Let's first locate this angle first. 4, -3. 1, 2, 3, 4. X coordinate is 4. Y coordinate 1, 2, 3. -3. So this is a point supposed to be on the terminal side. So let's okay. Okay, so the angle could be like this. This is angle theta. The point is 4, -3. 4, -3. And you see, in the trigonometric functions, you need a, b, r. But here you don't have r. You do not have r directly. R, what is the relation between r, a, and b? You see, 4, this is side 4. This side is 4. 4 is the x coordinate, so it measures the horizontal distance. -3 means this is a positive 3, because in the negative direction it's -3. So this side is a 3. And r is actually the hypotenuse. It's a right triangle. This is a right triangle. You see what I draw? It's from the origin, go down and horizontally to the point, and go back to the origin along the terminal side. So this is a right triangle. In the right triangle, the r squared is equal to 3 squared plus 4 squared, the Pythagorean theorem. Okay, so we get this relation, and r is the distance, so r is always positive. R is a 5. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. R squared is 25, r is 5. Okay, so we get r, a is 4, b is -3. So sine theta, y over r, cosine theta, x over r. Okay, so this is sine cosine. And after you determine sine and cosine, you get the ratio sine over cosine tangent -3 over 4. -3 over 5 over 4 over 5, they both have denominator 5, so you cancel that 5. Okay, I do the following thing. So you cancel the denominator 5, you get a -3 over 4. Or you multiply top and bottom by 5, you cancel the denominator from the top and bottom together. Okay, and after you get those 3 trig values, then you flip them, you get the other 3. So sine, the reciprocal is cosecant, is -5 over 3. Cosine, the reciprocal is a secant, is 5 over 4. tangent, the reciprocal is cotangent, is negative 4/3. And that is the answer. Okay? So this problem, this example also give us a relation a squared plus b squared is equal to r squared. You see? What is a? A is the length, opposite value of a. B, opposite value of b is a height. A is a horizontal distance, b is a vertical distance, r is a hypotenuse. Right? So a squared plus b squared is equal to r squared. So that's the universal definition for the trigonometric functions for any angle. For any angle. Okay, now let's check. Let's check some special values. We already know know the exact values for certain special acute angles. So now let's talk about other special angles. First, when theta is equal to 0, 0 reading or 0 degrees. If you do not put a circle here, I will consider this as a reading. If you put a circle here, I will consider it as degree. For example, if you just write 90, I will consider this as a reading, 90 reading. It's a very huge. But if you put 90 degrees, you have to, if you want to use degree, you have to put this little circle. Okay? So that's a mandatory. Okay, so for the theta equal to 0 or 0 degrees, then what is the corresponding terminal side? 0 means the terminal side coincides with the initial side. Okay, so the initial side is x-axis, terminal side is also x-axis. And then we just pick up a sample point from terminal side. For example, let's choose 1, 0. Let's choose 1, 0. Choose 1, 0. A is 1, B is 0. And the distance r is also 1, right? R is also 1. In this case, there's no right triangle. You don't need the Pythagorean theorem. You just directly measure this length is 1. Okay? So with this information, let's see what is a sine. Sine theta is y over r. It's 0. Cosine theta is x over r is 1. So sine 0 is 0. Let me use 0, not use a theta. Sine 0 is 0. Cosine 0 is 1. Cosine 0 is equal to 1. Cosine 0 reading is equal to 1. Okay, then let's see tangent theta. Tangent 0. Sine over cosine. 0 over 1 is still 0. 0 over 1 is 0. 1 over 0, undefined. Okay, so that's a difference. There's a difference. 0 over any number, any non-zero number is 0, but any number over 0 is always undefined. Okay, then let's flip them. Sine 0 is 0. You cannot flip them. So the cosecant 0, undefined. Cosine, you flip it, you get the secant of 0. You flip 1, you still have 1. Tangent 0, you flip 0, you get undefined. So cotangent of 0 is undefined. Cotangent of 0 is undefined. You cannot flip 0. Okay, so those are the 6 trig values. 0, 1, 0, undefined, undefined, and 1. But basically, you just memorize those two. Sine 0 is 0, cosine 0 is 1. Just from these two, you can get the other 4. B. Let's look at the right angle, pi over 2. Pi over 2, the terminal side is a positive y-axis. Terminal side is a positive y-axis. So let's pick up the point 0, 1 on the from the terminal side. So A is equal to 0, B is equal to 1, and R again is equal to 1. This distance is R, is 1. Okay, then let's check. The sine pi over 2 is y over r. Cosine pi over 2 is x over r. X coordinate. I always say x. It's actually x coordinate of this point. Okay, then let's see. Sine over cosine. You got a tangent. Let's put a tangent here. Tangent pi over 2. Undefined. Because you get a 1 over 0. Okay, so you have three things. And let's do the other one. Sine, you flip sine, you get cosecant. Cosecant pi over 2 is 1. You flip 0, you get secant pi over 2 undefined. And you flip undefined. Whoa, how do you flip undefined? Okay, check here. Tangent theta is sine over cosine. So by reciprocal, cotangent theta is actually cosine over sine. Even though we always flip tangent, but when tangent is undefined, you cannot flip an undefined number. So you have to start from this definition. Cotangent theta is cosine over sine. Cosine over sine is 0 over 1 is 0. Okay? Okay. So from these two examples, we actually have some observation. Let's check here. We are talking about the ratios A and B. Here, you see, tangent theta has denominator A. Secant theta also has denominator A. So if tangent theta is undefined, it means A is equal to 0. Okay? So if tangent theta is undefined, A is 0, then secant theta is also undefined. So tangent theta, secant theta, they are both defined or undefined. And similar thing happens for the cosecant theta and the cotangent theta because they also have the same denominator. Similarly, cotangent theta and cosecant theta are both either defined or both undefined. You will never see the case when the cosecant is good, cotangent is bad. You will never see that. Okay? So this actually the but you see here we have tangent undefined, secant undefined, cosecant undefined, cotangent undefined. They are always paired for the undefined situation. Okay, so check here, pi over 2, we get 1, 2. We get 2 undefined numbers and 4 good numbers, right? And then let's check the other one, C, the straight angle. Theta is pi or 180 degrees. So the terminal side is negative x-axis. Terminal side is negative x-axis. And we pick up the point like the negative 1, 0. We always choose simple number. We don't give ourselves trouble. Okay, so we get A equal to negative 1, B is equal to 0, and R is equal to 1. The distance between the point and the origin is equal to 1. And then let's check. Sine pi is y over r, is 0 over 1 is 0. Cosine pi is x over r. Negative 1 over 1 is negative 1. Then sine over cosine, we get tangent pi is equal to 0. 0 over negative 1 is 0. Okay, so we have those information. Let's flip them. You flip 0, cosecant pi undefined. You flip -1, secant pi is -1. You flip -1, still get -1. You flip tangent, cotangent pi undefined. See, the same thing, similar thing. Cosecant, cotangent, they are both undefined. Right? Okay, the other one. We already do 3 examples, so we possibly will do it very fast because we already have enough practice. Okay, so the other one, theta is 3 pi over 2. 3 pi over 2 means the terminal side is a negative y-axis, and we pick up the point 0, -1, 0, -1. Okay, so this is 270 degrees. So the A is 0 and B is -1. R is still 1. R is always positive. It measures distance. It's always positive. Okay, then let's check. Sine 3 pi over 2 is y over r, -1. Cosine 3 pi over 2 is x over r, is 0. And then tangent 3 pi over 2, -1 over 0, undefined. Okay? And then let's flip sine. You get cosecant 3 pi over 2. You flip -1, you still have -1. You flip cosine, it's a secant. Secant 3 pi over 2 is the reciprocal of 0, undefined. And you flip the undefined tangent 3 pi over 2. Remember, we are going to use cosine over sine. Cosine over sine is 0. Cosine over sine is 0. Okay, so this is the evaluation for the angle theta equal to 3 pi over 2. So on page 542, there is a table 4. The table 4 collect all the exact values of each of 6 trigonometric functions for 0. You see what we did. 0, pi over 2, pi, and 3 pi over 2. So you have 4 times 6. There are 24 values. And always simplify your job. You just memorize sine and cosine. And other 4 values can be computed through sine and cosine. You don't actually memorize those 4 times 6, 26 values. You just memorize 4 times 2, 8 values. Okay? And those 8 values are always well defined. Sine and cosine. They always exist. Okay? So this is the example. This is very important. This table is very important. Keep them in mind. So let's check here. For example, we have this. We have an angle in the standard position. Possibly your angle is like this, or your angle is like this. These two are different angles. You can see clearly this black angle is bigger than this red angle, but they share the same terminal side. Okay, so we're going to give name for those angles. Two angles in standard position are said to be coterminal if they have the same terminal side. So these two angles have the same terminal side. They share the same terminal side, or maybe this one. Let's see. It's positive this way. Where's my other? Let's see. Blue one. Okay, this one. This blue. These three angles are all coterminal, right? If they are coterminal, you will see that actually one angle, so theta 1, theta 2 are coterminal if and only if theta 1 is equal to theta 2 plus 2k pi for some integer k. For some integer k. How? You see here, this is a red one. This is this black one. The black one is actually the red one. Let's use this. This red one is a theta 1. This black one is a theta 2. This blue one is a theta 3. Let's check it. Theta 2 is actually theta 1 plus 2 pi. In this case, k is equal to 1. In this case, okay? And theta, okay. And the other one is theta 1 and theta 3. What is the relation? Remember, theta 3 is a negative. Theta 3 is a clockwise, it's negative. Theta 1 is a positive. So here, theta 1 is a positive. Theta 2 is negative. But they get a complete one revolution. So you have to write this way. Theta 1 minus theta 2. Negative theta 2 is this angle. So it is equal to 2 pi, one revolution. So you move this, theta 3. Theta 3, that's my bad. Theta 3, I'm talking about the relation between the red and the blue one. Theta 1 minus theta 3 is 2 pi. So theta 1 is theta 3 plus 2 pi. This is also the addition with 2 pi, k equal to 1. Okay? Any two angles are coterminal if and only if one is the other one plus certain integer multiple of 2 pi. They share the same terminal side. They will share the same trigonometric values because, see, since all trigonometric functions only depend on the terminal side. Of an angle, we get two coterminal angles have the same values of trigonometric functions. Okay, if they share the same terminal side, they share the same trigonometric values. Very good. So let's check. For example, if we are looking for the sine 390 degrees. 390 degrees. 390 degrees is 30 degree plus 360 degrees. So you can drop the 360 degrees. This is a complete round. It does not change the terminal side, right? So it is equal to sine 30 degrees. Sine 30 degrees, we know it's 1/2. Okay? Very good. Second, if we have cosine 420 degrees, well, 420 degrees, let's first simplify. 420 is 360 and plus 60, right? So it is cosine 60 because this angle and the 60 are coterminal. Cosine 60, we know it's also 1/2. Remember that there is a table to memorize it. Let me do it again here. And you have a my bad. I should draw it I should write it horizontally. I normally like the horizontal version. Sine, cosine. So here's a half root 2 over 2, root 3 over 2. 1, 2, 3. Here is root 3 over 2, root 2 over 2, 1/2. 3 to 1. Okay, 60 is pi over 3. It's a 1/2. Okay, keep this in mind. It's a simple table. It's not difficult to memorize. Okay, C. Tangent 9 pi over 4. 9 pi over 4. 8 pi over 4 is 2 pi, right? So it's a tangent 2 pi plus pi over 4. Well, 2 pi, you can ignore it because 2 pi plus pi over 4 and pi over 4, they are coterminal. So you get the tangent pi over 4. Tangent pi over 4 is equal to 1. D. Secant negative 7 pi plus 4. Well, we like a positive angle. I mean, at least I like positive angle. I don't like the negative angle. With the negative sign, it just gives us trouble. Okay, so let's add 2 pi. Add 2 pi, you do not change the terminal side. So you add 2 pi. 2 pi is 8. 2 pi is equal to 8 pi over 4. Negative 7 pi over 4 plus 8 pi over 4 is a secant pi over 4. Secant pi over 4. What is secant pi over 4? Secant pi over 4 is a reciprocal of a cosine pi over 4. Reciprocal of it, and this is square root of 2. N over square root of n is just square root of n. Okay. Secant pi over 4 is a square root of 2. And E. Cosecant negative 270 degrees. And similarly, I don't like the negative angles, so add 360 degrees. I change it to be a positive angle without changing the terminal side. Remember, I always keep the terminal side in order to have the equality. So 360 minus 270 is 90. I think we just did it, right? 90, where's 90? 90 is here. Cosecant 90 is 1. Cosecant 90 is equal to 1. So if you memorize that table, you can quickly get it. Okay, so that's a way to use coterminal trick to find the value of certain bigger or negative angles. Okay, so by this coterminal trick, we always have sine theta plus 2k pi is sine theta. You add 2k pi, you do not change. I mean, technically you put addition with 2k pi, but when k is negative, you actually subtract a certain integer multiple of 2 pi. So it doesn't matter you do addition, subtraction, you will have coterminal angles, you will have the same trig values. It works for sine, cosine, tangent, cosecant, secant, cotangent. You just copy them in list. Theta plus 2k pi, theta plus 2k pi, theta plus 2k pi, theta plus 2k pi, and theta plus 2k pi. And here is the cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. Okay? So, very good. So that's how it's an evaluation of some bigger or smaller negatively smaller angles. We know that we add or subtract 2k pi, you don't change the value. Next, let's recall the definition of sine cosine. Okay, sine theta is y over r. Cosine theta is x coordinate over r. Y coordinate over r, x coordinate over r. Okay, so let's check. R is always positive. Then if b is positive, sine is positive. If b is negative, sine is negative. So what we get? We get where b is positive. B is a y coordinate. When b is one point is above x-axis, b is positive. So let's talk about the sine. Sine is going to be positive, positive above x-axis, and negative, negative below the x-axis. Okay? Sine on top positive, on bottom negative, because the sine is determined by the sine of b, the y coordinate. For cosine, the sine is determined by the x coordinate. X coordinate on the right side positive. On the left side is negative, right? Negative x-axis, positive x-axis, positive y-axis, negative y-axis. Okay, so this is the sine of the sine and the cosine determined by the quadrants. And what is a cosecant? The cosecant is reciprocal of a sine. So when sine is positive, reciprocal is positive. When sine is negative, reciprocal is negative. So here sine and the cosecant, they share the same sign over each quadrant. And the cosine and its corresponding reciprocal secant, they share the same sign. Now let's talk about the tangent. Okay, tangent is sine over cosine. Positive, positive is still positive. Positive over negative, it becomes negative. Negative over negative is positive again. I'm talking about, you see, tangent theta is equal to sine theta over cosine theta when it is well defined. So we'll just compare the sign of each of the numerator and denominator. When in the final, the quadrant 4, you have a negative numerator, positive denominator is negative. So this is the sign in each quadrant for tangent. And cotangent is a reciprocal. So cotangent also have this pattern. So the first quadrant, all the 6 trigonometric functions are positive. And in the second quadrant, only sine is positive. Sine is positive, cosecant is positive. So we just list the sine. In the third quadrant, you see sine, cosine, tangent. Only tangent is positive. In the fourth quadrant, only cosine is positive. I just include the sine, cosine, tangent. Only cosine is positive. So to summarize this table, we get A, S, T, C. A means in the first quadrant, all the trigonometric values are positive. S means in the second quadrant is second position. Second quadrant, only sine positive, cosine, tangent are negative. Here, this formula only handles sine, cosine, and the tangent. Other three trigonometric functions are determined by the reciprocal, so you can determine them as the byproduct. Okay, so second quadrant, sine positive only. Third quadrant, tangent is positive only. Fourth quadrant, cosine is positive only. Aztec. Okay, I believe you know, many of you know this this trick to memorize the sine, and this is on page 544, table 5. Okay, table 5 give you the sine according to the quadrants. Okay, let's see the example. If sine theta is negative and the cosine theta is negative, name the quadrant in which the angle lies. Angle theta lies. Angle theta lies means the terminal side of angle theta lies. Okay. Negative, negative. You just check them. Only the third quadrant, cosine and sine, are both negative. Okay. In the third quadrant, sine theta negative, cosine theta negative, and that's it. That's it. Quadrant 3, or the third quadrant. Right? Problem 5. Actually, that's everything about the definition of a trigonometric functions of any angles. So far we have two definitions. One is about the trigonometric functions of acute angles. The other one is the definition of trigonometric functions for general angles. And now we want to connect them. To connect them, we need a concept called the reference angle. The definition, let's see the definition. Definition. Sorry. Let theta denote an angle that lies in a quadrant the acute angle formed by terminal side of theta and the x-axis is called the reference angle. reference angle of theta. Reference angle of theta. So that's a name. That's a definition. Let's see what is a reference angle. We have 4 situations. Assume the angle is in the first, the terminal side is in the first quadrant. I only say the terminal side is in the first quadrant. Possibly, I just say possibly the angle is like this. It's possible. If this is a theta, what is a reference angle? Reference angle is this one. This is a reference angle. Okay, just the acute angle formed between the formed by the terminal side and x-axis. And in the second quadrant, let's just make the life simple. If this is a theta, then what is a reference angle? This one. We need an acute angle, so you can only get acute angle between the terminal side and the negative x-axis. Okay, so this is a reference angle. In the third quadrant, then this one is a reference angle. The reference angle is not in the standard position. The reference angle is not placed in the standard position. And in the fourth quadrant, then the reference angle is this one. Okay, so it's always acute. It's always formed by the x-axis and the terminal side. Okay, so let's see the example. Find the reference angle. Find the reference angles for A. Assume our angle theta is 150 degrees. 150. The straight angle is 180. The straight angle is 180. 150 is like this. So this part is 30. So the reference angle is 30. Okay. And B, negative 45 degrees. Negative 45 is clockwise, so that's why you get the negative. 45 means it's diagonal. The reference angle is the same thing, but you just ignore the negative sign. Right? You only ignore the negative sign. That's the same thing. C. Angle is non-pi over 4. Let's see what is non-pi over 4. See, the whole thing is 2 pi plus pi over 4 is a non-pi over 4. Then what is the reference angle? This is the reference angle. And here is the reference angle, pi over 4. Okay, and D, negative 5 pi over 6. Negative pi is the complete straight angle, but go clockwise. Negative 5 pi over 6 is yes, negative 5 pi over 6. So this part is pi over 6. So the reference angle is pi over 6. Reference angle is always acute, it's positive, right? Okay, so after you get the reference angle, how do we get the relation between the trig values for the general angles and the trig value for the corresponding reference angles. The theorem is the following. If theta is an angle and alpha is its reference angle, and then what you have is the following. The sine theta, sine of the corresponding reference angle, they are almost same except a plus minus sign. Cosine theta is also equal to plus minus cosine alpha. Tangent theta is plus minus tangent alpha. And cotangent theta is plus minus cotangent alpha. And secant theta is plus minus secant theta is equal to plus minus secant alpha. Cosecant theta is plus minus cosecant alpha. Okay, so what does this mean? Plus minus sign, what does this mean? Where plus minus sign depends on the quadrant in which theta lies. So basically, alpha is an acute angle. So without the plus minus sign, sine, cosine, tangent, cotangent, secant, cosecant of alpha are always positive. But if you know that theta is in the third quadrant, then sine should choose negative sine alpha, because in the third quadrant, the sine theta is negative. So you will artificially put a negative sign. Okay? So for example, let's see this. We're trying to compute a sine 135 degrees. Where's 135 degrees? A 135 is actually 90 plus 45. So the reference angle this is a reference angle. Reference angle is another 45. It's 45 degrees. And the sine 135 is sine 45, and you have to see it's the second quadrant. The terminal side lies in the second quadrant. Second quadrant, sine is positive, so you just put a positive sign. And then put a positive sign, you don't change it, so it's square root of 2 over 2. Okay, so that's the first example. You first find the reference angle, you compute the corresponding trig values, and then you determine the sine of the original trigonometric functions based on the quadrant. In the second quadrant, the sine is positive, you just put positive sign. Positive sign does not change any value, right? Okay, let's see another one. Theta is 600. 600. Oh, what is 600? 600, 360 plus 240. Okay, so 360 is one round, and you get a straight angle is additional 180, and get another more. So this is a 600. And this, you see, from here to this point is a 360. And then you plus a straight angle, it's 180, and then you add additional 60 degrees. So the reference angle is 60 degrees. Reference angle is 60 degrees. So the we're talking about cosine of 600 degrees is equal to cosine 60 degrees. This is third quadrant. In the third quadrant, cosine is negative. You just put the negative sign. Cosine 60 is 1/2, so the cosine 60 degrees is 1/2. So the cosine 600 degrees is negative 1/2. Okay? Okay, we stop this video and we'll continue the discussion in another short video. Okay? Well, let's stop this.